Good morning and welcome to the podcast today with our fabulous space cadet Gitika Gorthi. So Gitika, just tell me a little bit about yourself.
Yeah, thank you so much for having me. Like you were mentioning, my name is Gitika, and I'm an incoming freshman at Columbia University in their College of Engineering and Applied Science, and I'm the founder and CEO of Ignited Thinkers, which is a nonprofit organization I founded in the eighth grade to spread space education to students across the world. I'm an aspiring aerospace physician and astronaut. I'm especially very excited about the intersection between space and biology and all that we can discover about our bodies and how we can translate that into advancing medical technology here on the earth as well as out there in space. And so that's a little bit about me, and I aspire to hopefully one day go to space and become the first doctor on Mars.
Okay, cool. So you're heading to Mars.
I hope so one day.
Have you always had that ambition, or are you? Because you're very young still, anyway. But when you were younger, have you had that ambition to get to Mars?
It's always been a goal that like I want to go to space. Like I think that's always been like something intriguing and interesting for me as a young kid. I didn't think it was realistic, and going into I think I have this whole journey that really shows how got into aerospace because I was always intrigued with space as a young kid, but I didn't think of it as something attainable or something that I could do realistically in the future until a middle school rocketry club. And ever since then I started like deeply exploring space, which I can get into if you're interested. But I slowly started getting deeper and deeper into space, and coming into high school I realized how it was possible for me to go to space and how we can and are planning to go to Mars and have human presence on Mars within the next 15, 20 years maybe. And that gets me excited, and it seems like something that I would, if given the opportunity, I would jump at it.
Is that common to your kind of age group that the expectation that we will go into space? Is that something that's around your age group a lot, or is it? Are you fairly unique?
In terms of if you go to school and you tell someone that I want to go to space or humans are going to go to Mars, it's something that people are not very as excited about. It's not something that's commonly talked about with my friends or within my age group. But if you surround yourself with all the aerospace lovers, I'm sure there's tons and tons of students my age who are intrigued by aerospace. But it's not as common to just go to school and talk about going to space. It's not something that everyone talks about.
Yeah, it's cool. I find it. I'm 58, so when I talk about it, and I fully expect that my children who are in their early 20s will have the opportunity to go to space, and I fully expect my grandchildren who haven't even been born yet will probably live in space. There'll be somewhere that can some one of them that will live in space. Um, but when I talk to people about this, they look at me slightly strange and think I'm bonkers. They think about it and they might think, well, that actually might be true. It's just they've never thought of it. It's not really in their consciousness at the moment that fairly soon we'll be in space. It's so exciting. And I look at the young people that I talk to and think, why aren't you excited as I am about this? But it's still fairly uncommon
Yeah.
to really understand what's going to happen in space and think about what's happening in space. So that's absolutely brilliant. Good for you. Were you a sci-fi nerd when you were a kid, or
Yeah,
not?
I can get into that a little bit. What got me intrigued with space, and I guess what you were mentioning a little bit earlier to comment on about it. Space is not as common of an industry that students talk about when they're in middle school and high school. Like, I want to go into this career in aerospace when I grow up. It's not something that's extremely common, and I'm sure that's one of the reasons I founded Ignited Thinkers. So, growing up as a first generation student in America, young girl, both my parents are in completely different industries, not in the aerospace field. So I didn't have a lot of aerospace growing up. It wasn't something that I was like, oh, I'm going to be this when I grow up. It was more of a fascination with why does everything I drop fall down to the ground? Like, how come everything just comes down? And how come the moon seems to be following me everywhere and changes shape every day? Like, just curiosities like that got me thinking about aerospace. And I started watching Star Wars and Star Trek growing up a little bit. And that got really, me excited about science fiction and aliens and the idea of going to space. But again, never thought of it as something that I could be or something that I could do. And it's because maybe I didn't have role models in my life who did it themselves or people who I could look up to. And so, growing into elementary school, I got a really keen fascination for biology and the human body. And this was more in my realm because I had a lot of relatives and family members who were interested in medicine. So for me, it was like, oh, I love the human body. It's also curiosity questions that got me intrigued. Oh, what's inside of my body? What happens? Why is there bacteria in my body? What's happening? And curiosities like that got me really intrigued with biology and medicine. And going into middle school, I was like, oh, I'm going to be a doctor 100%. This is my career. This is what I want to do. And one of my electives in middle school, you might be familiar with this. You can take like an elective of your choice, and at least here in middle school, you can. And I chose tech ed, which is engineering and design. And I just took this class because it was very common. A lot of my friends took it. And going into this class, I had no expectations, but we had a model rocketry unit in the school. And I absolutely fell in love with rocketry and was fascinated with building them and flying them at the back of my school. And my tech ed teacher, Mr. Alan Anderson, he noticed my interest and it was so excited to see how excited I was about model rockets and was like, Gitika, why don't you join my middle school rocketry club after school? And I was like, I don't know. I don't know if I could build a model rocket. I'm not smart enough and I love this. At the time I was like, you know what? I'm just going to give it a try because if he thinks I can do it, maybe I can. And so being me, I just joined the rocketry club and I fell in love literally even more than in the class itself. I spent every day 1 or 2 hours after school outside of the club, just in his classroom, building model rockets, starting off with the kits that SD's has, and then started designing my own using the laser printer my school had and just went crazy with model rocketry. I got my NARTREC certification, which is a model rocketry certification that students can get, and just kept building my skills in that. And that summer, I was like, I need to experience more of space further, seeing how excited I was. And I applied for a NASA summer program for 1 week. It was called the Sisters Program. It's completely a free program for young girls who are in middle school. And I applied for the program, and I was one of the 35 girls who were selected. And I was very excited. And I went down to Maryland. My dad drove me to Maryland every morning for 1 week. And I was able to experience what it was like to work at NASA for a whole week. And it was amazing. I visited all the laboratories. I saw the flight launch sites. I saw like the different experiments the scientists were doing. And I was just mind blown. And I knew this was a type of environment I wanted to work in growing up. And so
Hmm.
at that moment, I think I was really inspired to go into aerospace.
Okay.
And going into high school, I was like, I need to combine my interests because I love biology. I couldn't give up on my interest with biology because I took an AP bio class in high school and I loved everything about the human body. And I loved space, which seemed like two completely different avenues for me because I was like, am I going to go into engineering? Am I going to go into biology? And then in high school, I randomly searched up on the internet space medicine, putting two words I love together. And I found out that it was a real career. And
It's a
you can,
thing.
it's a
Yeah.
thing, it's a real thing. And you can be a flight surgeon, you could be a doctor who helps astronauts, but also you can translate that research into helping humans on Earth. You can understand and like the human body in a completely different environment by taking out the element of gravity, and you can discover so much more we didn't know previously and apply that into helping advance treatments here on Earth. And I can get into
Hmm.
like my research if you're interested, but ever since then I've been trying to find opportunities related to aerospace medicine. And in the middle of this process, I founded a nonprofit, Ignited Thinkers, in the 8th grade. And when I was in middle school, and I can get into this if you're interested, maybe I don't want to take up too long of an
Yeah.
answer, but that was my passion for finding aerospace medicine and coming up with my goals of becoming an aerospace physician.
Okay, cool. And you definitely think you're going to space?
100%. To some extent, I
Good.
will.
Yeah, yeah, one way or another. And are you getting involved? Is there an opportunity to get involved kind of in the astronaut program and how that works? I don't really know how that would work, but
Yeah.
are you involved in that?
Not currently. I know there's a really famous or popular one, the Possum Project, and I did, apply for this program just recently, a few weeks back, to get astronaut experience. But I have been trying to, save up money to do my skydiving certification, hopefully one day do my scuba diving certification. And actually, since I'm going to Columbia University, as one of our requirements, we have to take a PE class, something fitness related, and they have scuba diving certification. So I think I'm going to be
Okay,
doing
cool.
my scuba diving certification in college. But I'm like trying to see what do astronauts require and doing my own research and trying to check those boxes myself. But I know there's a lot of inbuilt programs for students to take part in, and I haven't had the opportunity to join them, but hopefully one day I can.
Yeah,
And there's
if you,
also analog missions and things you can do in college, but they require a lot of education. And I've
yeah.
just got my high school diploma.
Yeah, just working through it. I used to teach scuba in the Cayman and in Hawaii as well. Yeah, that was a lot of fun. But at that time, I certainly wasn't thinking about space. I was more thinking about just the coolness of looking after the people on the 7,000 foot drop off just on North Cayman. But that was pretty cool. But so if you're combining your two interests, I'm going to ask you a really unfair question now: space or medicine? Which would you prioritize if you had to make a choice?
Yeah, I don't have to because I can combine them
No, of
together. But if I had
course you
to,
can.
if I really had to like pick one of them, I think, oh, that's really tough because this is the same dilemma I had in high school, and I was like, I'm not going to like pick one, but I think I would go. That's really hard. I don't know. I don't think I could ever pick. I'm so glad there's aerospace medicine. I think one thing I
Yeah.
love about space is it's so interdisciplinary. And I feel like space is not just, you don't just study space, you study something else that applies to space exploration. So I think when it comes to space, it's so much more open and it requires interdisciplinary studies. So yeah, I think it's like hard to pick between the both.
Well, the good news is you're probably going to live to 120, 150 years old, that sort of longevity. So you've got plenty of opportunity to do both. Maybe not both at the same time, but both combined even a little bit later on. So when do you think, what's your gut feel for when we'll be living, well, you want to go to Mars. So when will we actually get to Mars and when do you feel that there'll actually be a colony on Mars?
Yeah, that's a tough question. I was recently at the International Space Development Conference in Washington, D.C., ISDC, and I was listening to a few professionals at NASA who are more of the governing people talking about going to Mars and how that timeline would look like. And everybody was asking questions about the timeline, and they didn't have an answer because they have a plan of we want human presence by this year, but it always gets pushed back because there's always challenges, new issues, political and non-political, that always come in the way. And so the timeline keeps changing. But if I had to predict, I would say I think 2035 just seems like a really good year to do. I don't know. It just seems like it's early. It's a little bit more than 10 years, but I think that we've been rapidly growing every single year with commercialization speeding things up and with NASA being that, voice and being a catalyst for these commercialization industries to take place, like SpaceX, Blue Origin. They're really competing, and there's a lot of not just political competition, but also this commercial competition that's pushing things to go faster and faster in the industry. And I think that we could do it in 10 years, a little bit over
Yeah.
10 years. I think we could do it. At least have human presence on
Yeah.
Mars.
Yeah, I think there's a reasonable chance we could have a human presence on Mars. I'm thinking about 50 years, there will be a colony on
Oh,
Mars
a
within
colony.
50
Yes, a
years.
colony will definitely take time. I think right now we're just shooting to get the human presence on Mars.
Yeah, yeah. Get some footprints
Yes.
down on Mars. And it's interesting when you look at the nation states that are involved in the space exploration and with all the things that go on the planet, that there's still a little bit of communication going on around the International Space Station and then the Chinese space station that's up there. I'm very much hoping that we'll find a way of combining the national efforts into a more interplanetary effort as we go forward and solve some of the engineering problems with brains and insights from around the planet rather than just the Western world. But we'll have to see how that goes.
Yes.
So tell me a little bit about what do you say, inspired thinking,
Ignite. Yes.
ignite, yeah.
Yes. Ignited.
Ignited thinkers. Tell me a bit about
Yeah, so Ignited Thinkers is something that I found in the eighth grade, and I'll tell you a little bit. So when I told you a little bit about what got me into space in middle school was really the moment a lot of things changed for me. And in middle school, I took my parents to my first big model rocket launch that I couldn't do at the back of my middle school because we're near an airport. So there's definitely a height limit of how far you can launch a rocket. And I was launching a bigger rocket, and so my parents had to drive me down to the big fields, Great Meadows, and it was like 45-minute drive. And so I dragged my parents along, and this was the first time they were going to see my rocket launch. And we went to the rocket launch. I launched my rocket, and on the car ride back home, my dad said something that really changed my perspective. He was like, Gitika, you're so lucky to have this incredible opportunity to build and fly a model rocket at 13. I'm like 41 and I still haven't built a model rocket, or this is my first time seeing a model rocket even launch. So you're so lucky to have this opportunity. I'm sure so many kids around the world didn't have this opportunity and don't have this opportunity. If I did, maybe I would have gotten into aerospace. And that one statement from him, of like him talking about how lucky I was, made me realize, wow, if I didn't have this middle school experience, if I didn't have this tech ed, class, if I didn't have a model rocketry unit, and if I didn't have this club, I wouldn't have ever gotten into space, to be quite honest, because it was always a fascination. But if I didn't have someone to provide me with the confidence that I could build a rocket, or I could really be smart enough to go into the aerospace industry, I would have never considered it a real career option for me. Being someone who doesn't have parents in the industry, it just didn't seem like something that I could do. And just seeing how this club changed my experience and formed my thinking and made me so passionate about aerospace, I knew that I needed to do something to provide this middle school club experience I had to every student around the world. And so at that moment in eighth grade, I formed an entity called Ignited Thinkers, and ever since then have been working to provide this middle school experience I've had to other students, whether it be through free workshops, webinars, creating online resources such as my YouTube channel, being active on social media, helping students form their own clubs, and providing resources to start those clubs. And working towards creating kits for classrooms. This is a new project. We're working with various counties in the United States and hopefully other countries soon to be able to produce these kits and have in classrooms directly
that.
to
Okay.
inspire students. And working with different companies like Teachers in Space and SEDS USA, and really trying to work to foster this community for younger students, K through 12 students, to get inspired and ignited with aerospace. Because a lot of companies right now are so focused on recruitment and employment, and a lot of programs are geared around college students. But I think that a lot of passions for younger students develop at a younger age, and we need to
Mhm.
provide this opportunity for them. And so I've been working towards fostering aerospace passions for K through 12 students and showing them that aerospace is not just math and physics and you get to be like a rocket scientist. There's a lot more to it. And so every time I go, I talk
Mhm.
about the various career opportunities and how you could be a food scientist for NASA. You could go
Mhm.
into space art, you can go into space policy, journalism in space, and kids are so like excited and they're like, wow, I can really do that. And just knowing that I can break those stereotypes that are there around the industry makes me really excited. And that's something that I get to do through Ignited Thinkers.
Awesome. That's really good. So, a couple of questions. This rocket that you built, how big was it?
Yeah, the first ones that I built were like a 1 foot. I believe they were like not too big, and the later ones got really like a lot bigger. So the high-powered rocket that I'm working on currently is around 5 or 6 feet. It's like pretty. It's really big. It's really tall, and then you can use different types of motors. The one that I'm shooting for right now is a D motor, so it's not too high, but it's enough for the rocket. I
Yeah.
shifted my passion from rocketry to something I'll do during my free time. And I'm currently really focused on my research experiences with aerospace medicine because that's the career that I'm truly intrigued by. And so I
Uh-huh.
do internships with NASA. I work with Columbia Medical School, Brown University of Central Florida, Baylor College of Medicine, Space Medicine Center to do some of these research experiences that I'm passionate about. And so I diverted a little bit. So I'm not as focused on the rocketry part, but it is a critical part
Uh-huh.
to what got me into space.
Yeah, the things that explode. That's kids like things that
Yes,
explode and go up in the air.
exactly.
Yeah. That's cool. So what's the research? What is it that you're researching?
Yeah, so currently what I'm trying to, okay, so I can talk about my most recent research experience, which was at NASA Ames Research Center, which is in California.
Okay.
I did this
Yeah.
during COVID, so the internship was virtual, but it still was a great experience because I analyzed these different genes, gene sets, gene data that was captured in a SpaceX launch. So a SpaceX launch took these fruit flies, which are Drosophila, very tiny bugs, and
Hmm.
they took them to space, 30 of them in space, and there were 30 on ground that were monitored. And what happened
Okay.
was they collected data on these flies' cardiovascular system and how different genes in their cardiovascular system changed in space compared to ground control. And so my job
Okay.
as the virtual researcher was to analyze these genes, go through these gene sets and see was anything abnormally or statistically significant enough to be very upregulated or very downregulated, which means was a certain gene abnormally behaving in space compared to on Earth? Like, was a gene excessive in production, or was a
Hmm.
gene not even functioning in space at all, like how it does on Earth? And so we kind of identified, my team and I, we were a group of three. We identified certain genes that were behaving abnormally and started researching about these genes. Do we know about them? Do they have a function on Earth? And we identified a few actin genes, which are responsible for contractility in your heart, muscle contractions in your heart. We
Hmm.
observed that they were behaving abnormally. On Earth, they both compensate for each other. If one gene increases, the other one decreases, and they compensate. But in space, they weren't compensating for each other. They both were just abnormally increasing. And so we were like, what does
Okay.
this mean if they're not compensating and they're behaving weirdly in space? And this is related to muscle contractility. What does this mean for these fruit flies? And you might be wondering, why studying these bugs? Why do they matter? Well, 75% of the cardiovascular diseases that are in humans are in these fruit flies. We can observe the
Okay.
same behavior in these tiny bugs, which is, it's just unimaginable and it's crazy to think, but it's true. And so using these tiny bugs, we're able to identify certain abnormally behaving genes, and then we can find the human parallel. So is this actin gene in humans? And if it is in humans, did we observe the same abnormal behavior in these human tissues in space? And what could that mean in the long run? Currently, we haven't faced a lot of issues with the cardiovascular system as far as we know in astronauts that have been in space. But as we look into going into Mars and further, what could this mean to our human health and our overall health in space? And so, understanding questions like these is what I did in my internship, and I focused specifically on the cardiovascular system. But I started getting into other research experiences with Columbia Med, where I'm researching on radiation. So in space, as we
Okay.
know, there's a lot of radiation. And so what does that radiation do? How can we, this is the same thing I did at Baylor as well, where I understood what are some countermeasures to radiation? What is this radiation doing to our body? How much is actually seeping through our skin and not just in the instruments in the, in space? And what does this mean to our overall health? And understanding this radiation can then help us translate into helping improve cancer treatments. Right now, radiation is very harmful in cancer treatments on Earth. And so what can we
Hmm.
do to better this radiation treatment that we have to protect the health of cancer patients? And so translating these questions is something that I'm really passionate about. And I think space provides this very unique environment for us to research about humans in a faster way, in a more quicker manner that we can do here on Earth. So that's kind of like a glimpse into my research.
Cool. That's it. So, kind of, where do you see that going then? What's the translation for kind of normal people when that extrapolates out and starts to become something tangible that normal people on Earth can benefit from? What would you see that doing?
There is going to be a huge advancement. There's two things I would like to really specifically mention. One is telemedicine. As we are starting to use artificial intelligence in space with in much greater extents, and as we're trying to go to Mars, unless we have a physician on board, you need someone there to constantly, like an AI, a robot, to be able to provide medical support. Because by the time if something happened in space, like all the way near Mars, to get transmission back to Earth for medical help is going to be very slow. At 20 minutes, 30, it's going to take a long time. We improve communication somehow, but it's going to take a long time. And so we need an AI bot or a physician on board. And so telemedicine is really going to become more efficient. We're going to start having personal robots to help us with our healthcare. And I think
Hmm.
that type of advancement innovation that'll happen in the space industry for astronauts can then be more accessible to humans on Earth. So if you are someone, as things start to get cheaper and they're produced in mass, just like iPhones, they can starting to be accessible to every human to have in their houses. If they have an emergency, they're not feeling well, they could have a personal bot to assist them. Of course, this is very future thinking, but I think telemedicine will advance greatly due to space exploration to help humans on Earth. Additionally, to give a direct example, in space, you must have definitely heard that there's a lot of bone density loss. If astronauts don't
Hmm.
exercise in space, they just lose a bunch of their density and the bone density. And this very quickly in space. But on Earth, bone density happens over the loss of bone density happens over a long period of time. Like when you're 80 or 70, it starts hitting in very slowly. But when you're in space, it's very quick because you don't use your muscles. And so we can understand what genes are involved in this process of bone density loss and what genes can we target to research here on Earth to potentially discover solutions to prevent bone density loss for elders. So just research like this is what will really benefit every human on Earth.
Yeah, it's amazing when you look at the amount of technology that was developed on Earth as a result of the last big push into
Thanks.
space.
Exactly.
There's so much going on. And when you look at the experiments on the International Space Station at the moment, for example, I think all of them, or certainly almost all of them, have a space application and an Earth application as well. It's fascinating how that's benefiting the human population in the near term. Because as we were discussing earlier, lots of humanity doesn't really understand what the benefits of spending money going to space are, but there's
Exactly.
so incredible amount of benefits that will come back for most of the population of the planet, which won't go into space after all. Certainly the living population at the moment is not unlikely to go into space, but I think it's fascinating when you look at some of the episodes of Star Trek and those sorts of things. Where was that pitch? Where's the timeline of that pitch? Because it starts to become possible. You can start to think, I don't know, in 500 years, 1,000 years, why not? That is entirely possible because some of those technologies are beginning to be worked on now.
Exactly.
Fascinating stuff.
Exactly. And a lot
Yeah,
of
cool.
technology, if you look at Star Trek and Star Wars, a bunch of the unrealistic technology kind of models what we're trying to work right now. So
Yeah, yeah, yeah. Really interesting stuff. Cool. So if I was to say to, if you were to say to the audience, what's the one thing that you'd really like somebody listening to you and hearing you speak at the conferences? What's the one thing that you would love them to pick up from listening to you?
yeah, one thing that I would love to leave every single person listening with is you miss 100% of the shots you don't take. And also, space is for all. Growing up into the space industry, finding ignited thinkers, it may seem like, oh, she had a path for her, or she is like a genius and she was really into this from a young age, which is why it was possible. But that wasn't the reason. It was because I took every risk, every opportunity to put myself out there. If I didn't put myself out there, nobody would even know who I am, or nobody would even care to take part or collaborate with my organization. I had this idea, but to make it a reality, I took a lot of risks. I put myself out there. I went out of my comfort zone, and I think those are the moments where you grow yourself. And so, regardless of any passion or any career you're interested in, just knowing you have to take risks, and just knowing that if you don't take a risk, you're never ever going to see if that risk would work out. It's just something to remember. And also, if you are interested in an aerospace career, just remember space is for all. It's not just for a certain group of individuals. You don't have to have your master's or PhD degree. You could be a 13-year-old who's really interested in space, and I guarantee you there is an opportunity for you to contribute to some extent. Age, gender, identification, your ethnicity, your socioeconomic status, geographic location, none of that really matters today because there are so many more opportunities that are opening up for every single person, every single individual to be part of. And so, something that I would like to leave everyone with is if you really are interested in aerospace and if you have a drive and you have a passion, then just start young and know that space is for all. And there's so many opportunities out there just for you. You just have to look for them.
Yeah, fantastic. Great words. Very inspiring. Thank you so much for spending the time to talk with me today. and I'm sure we will talk again in the future.
Definitely. Thank you so much for having me. It was a pleasure speaking with you.
All right, take care now. Bye bye.